In this question we are told to find out the condition that A, B and C should satisfy such that 3x plus 4y plus z is equal to A, 2x plus 6y plus 4z is equal to B, and x minus y minus 2z is equal to C. These three equations have at least one solution. We are told that A plus B plus C is not equal to 0. So let us write the first equation as 1, the second equation as 2, and the third equation as 3. The second equation let us divide by 2 because the coefficients on the left hand side, all of them are multiples of 2. So if you transform the second equation, you will get this to be, if you divide it by 2, you will get x plus 3y plus 2z is equal to b by 2. Let us call this the second equation divided by 2. Now, if you are comparing the three equations, this is the first equation, this is the second equation, and this is the third equation. When will the system of equations have no solution? When does it have one unique solution? And when does it have infinite solutions? To do that, let us first try to transform the third and the second equation into the first equation. So let us assume that we multiply the third equation by a number a, and we multiply the second equation by number b. Then suppose we are going to get a equation which is identical to the first equation, especially with respect to the coefficients. We will ignore the right hand side part for now. Let us just try to transform it. What we are basically saying is, if you are multiplying 3 into a and adding the second equation divided by 2 into b, we will be getting a plus b into x plus 3b minus a into y plus 2b minus 2a into z. This will equal on the right hand side b into b by 2 plus a into c. Now we are saying that this equation is identical to the first equation if and only if all the coefficients match, that is a plus b is equal to 3 and the coefficient of y is 3b minus a is equal to 4. So we will solve this system of equations and then we will see if the third coefficient also matches. That is, once we solve this, we are going to get a value for a and b. Now if 2b minus 2a, which is the coefficient of z, is equal to 1, in that case this system of equations either has infinite solutions or no solutions. If 2b minus 2a is not equal to 1, then this system of equations will have exactly one unique solution. It will have one solution, you don't know whether it is unique or not. You can at least satisfy and calculate the value of 1 of x or y or z, and based on it, in most cases it will have one solution. Now if 2b minus 2a is equal to 1, there is a case where there are infinite solutions and there is a case where there are no solutions. There will be infinite solutions if even on the right hand side the numbers match. That is b into b by 2 plus a into c should equal the right hand side, which is equal to small a. If this equals, that is even the coefficient of the constant term match on both the equations, then the system will have infinite solutions. If the constants don't match on the right hand side, then the system of equations will have no solution. To calculate it, let us first solve the equations. A plus b is equal to 3 and 3b minus a is equal to 4. If you add both of them up, you are going to get 4b is equal to 7 or b is equal to 7 by 4. Therefore a, which is equal to 3 minus 7 by 4, is equal to 5 by 4. Therefore, if you are looking for 2b minus 2a, this will equal 7 by 2, which is 2b, minus 5 by 2, which is equal to 1. So 2b minus 2a is equal to 1, and because the coefficient of z also has matched, this would imply that the system of equations either has infinite solutions or no solutions. Now it will have infinite solutions if even the constant terms are equal. That is b into b by 2, which in this case will be equal to 7 by 4 into b by 2 plus a into c. A is 5 by 4 into c is equal to small a, which is equal to small a. If you multiply the entire equation with 8, you are going to get 7b plus 10c is equal to 8a. So So the system of equations will have infinite solutions if 7b plus 10c is equal to 8a, and it will have no solutions if 7b plus 10c is not equal to 8a. Here we are looking to find out if the system has at least one solution. So the correct answer is that the condition has to be 7b plus 10c is equal to 8a. Just to reiterate, what we have basically done is we have transformed two equations such that the coefficient of x and y match the same as the first equation. You can pick any two equations, you have to just transform both of them such that the coefficients of x and y are equal to the third equation. Once you get the x and y coefficients to be the same, you check if the z coefficient is also the same or not. If the z coefficient is also the same, then it would imply that the system has either infinite solutions or no solutions. It will have infinite solutions if even the constant term match. So in this case, for the constant terms to match, you will have 7b plus 10c has to equal 8a. If the constant term doesn't match, then the system will have no solution. Anyway, the answer in this case is 7b plus 10c is equal to 8a.